I am getting better at this all the time, but still suck at it. By the way, I proposed this talk. Like at the time I proposed it, I think I was like not thinking about standing up in front of everyone and like dissing Redux, which is not what the talk is about. It's since been renamed in the course of like submitting it to a conference. So don't worry, it's not that. Just ignore that. There may be like 1 or 2 Redux jokes in there. I use Redux every day, just FYI. OK, cool. All right, just briefly, before I get into this, a bit about me. My name's Hannah Howard. If you're on the internets, you can find me. That's like my handle at TechGirlWonder. I use this as my little avatar. I've only made 1 good drawing in my life, and that is it. And I never intend to draw again. My preferred pronouns are she, her. I work for a company called Carbon 5. We are a product development agency. We work with all kinds of clients, from like small startups to like big enterprise companies, and we take whatever their product needs are. We take them from like the very first idea all the way to completion. I'm acting as our recruiter tonight, I guess. So if you're interested, talk to me afterwards. I have no business cards. OK, so the new title of this talk is, I'm going to have to, it's a little, yeah, it's fine, cool. The new title of this talk is, can everyone hear me? Is the mic, yeah, OK, cool. The new title of this talk is RxJS, a better way to write front-end applications. So that's that. Briefly, very, very quick content warning. There is like a couple of pretty jarring animations in this. Not like hugely jarring, but if anyone here is maybe susceptible to like seizures or whatnot, like probably not a concern, but I just want to put that out there. Also, just so you're ready, there will be heavy pop culture references. I am from LA. And I just gave this somewhere other than LA, but I am actually from LA, and I was born here. So if you can't keep up, just live in LA a little longer and you'll get all the images. OK, cool. So good evening and good morning to all the legendary children, and welcome tonight to the Functional Reactive Programming Ball. Tonight, the category is, what is a computer program? So, interesting question. What is a computer program? This is something we work on every day, but maybe we don't think about it. So a very important computer science textbook that I refer to frequently in my job defines a computer program as a sequence of instructions for performing a task designed to solve specific problems. So I want to focus on that statement about sequence of instructions, because that's the one that I like always think about. It's like, oh, it's a sequence of instructions. It's like you think of like a program as almost like a to-do list, right? It's like I'm going to do this, and then I'm going to do that, and then I'm going to do that, and then I'm going to get to the end. It's like a sequential list of things to do. If you were to think about it maybe in a different environment, you think about it in like a school environment, teachers come in with like a lesson plan, right? So it's like, I'm going to go in, I'm going to teach this, I'm going to teach that, and then we're going to do this, and then we're going to do that. And that's kind of like how I often think about it. But then I've been wondering a lot, is that really accurate? And if you're writing like a command line tool for a backend program, you might be able to rely on things happening in sequence. But this is the js.la meetup. So I imagine some of you here are front-end programmers. And my question is, maybe is a sequential program really an apt metaphor for how front-end programs run? Because I think this is a better metaphor for how programs run. Front-end programs don't run sequentially. Front-end programs, the flow of execution is constantly interrupted by user input or responses from back-end servers. There's like a million other things that could interrupt your programs, working through a sequence of instructions. You have way less control. It's like an unruly classroom. And in fact, I would argue that interruptions are kind of like the central challenge of writing front-end programs. Front-end programs are pretty useless without responding to user input or talking to a server. In thinking about, so how do we deal with that? So I want to just do a brief history of how we have dealt with interruptions on the in computer programming, not at award shows. So I'm going to talk about a couple of historical techniques for how we deal with interruptions before I talk about what I consider my proposed solution. So I've been programming since 1992 or 3 maybe, with a big break in the middle. But when I first started programming, the very first type of programming that I did was DOS games. DOS is Disk Operating System, for those of you who may not know what that is. It was an operating system in the late 80s and early 90s on a lot of PCs. And so I want to talk about, so we had this technique for dealing with user input back then called the global event bus. So basically, the way you could do this in DOS is you could basically take over the keyboard of the computer, which literally means you would, this is the code to take over the keyboard. This is C code. Don't worry if you don't understand it. It's actually not so important unless you care about C code. The main idea is to get a sense of what's going on here. So this is actually replacing the underlying handler for your computer, like the actual hardware handler. Well, it's something called BIOS, but it doesn't really matter, with your own code to be the first thing to process keyboards events as they come in, right? And so you would do that, and then oh, wait, sorry, 1 second, I gotta get this right. And then this is your code that you would put in to handle the keyboards. It's not even clear what it's doing, but what concretely you're doing is recording the keys and putting them in a buffer. And then the rest of your program would look something like this. You can see that it is essentially a main function with a big loop in the middle. Actually, it's not even that close to the middle on this screen, but it's near the bottom. You can see it says while not done, run forever. And on each iteration, check what your last input was, the last event that happened. It could be coming from the keyboard or from the mouse or maybe a joystick, and then handle it, right? So check the input, try to figure out what it is, and then do something based on it. So you have an infinite loop where each iteration processes a single event coming over what we would call an event bus, right? Yeah, and you can see this is where you would somewhere in this if clause is where you would process the input. The only issue with this is if you ever wrote a bad interrupt code to collect keys from the keyboard, you can see here we have an infinite loop in our function that runs every time someone types a key. The problem here is that you've actually overridden your computer's ability to read the keyboard itself, which means that you cannot control C out of this program. You have to reach down and press the power button on your computer to try to get it to reboot. So that's the downside of that. Obviously, kind of sucks. I moved on a little bit to Windows programming. In Windows, they improved a little bit by basically taking control of the actual hardware away from you and having the operating system process the input. But you can see that there's that same basic loop at the bottom there, where you've got, essentially the loop is basically read a message and then do something with it, right? And so then the main part of your program would be something like this, which is what we used to be. Doesn't really matter what it is, but what it's called. But it is a procedure to take one message, and based on the type of message, so you get a message, and you have a big switch statement in the middle, and based on the type of message, you do something to update the state of your program. Right? So it's a big switch statement where you get different types of messages, and you have to update your program based on that. So that brings us, and that's kind of the way it was. It takes us all the way to 1999. And then we left the concept of this event bus in the dust for better things. Or did we? So if you look at this structure, anybody who's doing front-end program these days, particularly if you happen to be using certain tools, you might be, if you look at the structure of a function that takes the state and a message, and based on the type of message, you have to update and get a new state. Well, that looks a lot like a Redux reducer, right? So, which is the same idea. Type of message, update the state, return the new state. So So Redux actually uses a so-called global event bus pattern. And it's similar to the global event bus pattern. And while maybe Redux feels like it's programming like it's 1999, there are some good reasons for this. And this is not a shade to Redux talk, despite its original title. It's evolved since then. I've become a better person. Anyway, there are some reasons they chose that, and we'll get into that in a second. OK, moving on. I want to talk briefly about the big pattern that we've been using basically since then. It's called the observer pattern. How many people have heard of the observer pattern? Oh, wow. This is like a super advanced group. Actually, until I did this talk, I had heard the word observer pattern, or the words observer pattern like 100 times. And I probably would have said that I could explain it, but I'd never really thought about it. And I don't actually think I did know what it is. So, but it is the basic pattern by which we've been writing user interfaces for the last 10 to 15 years. And so I want to explain this because it's going to become important later in the talk. And to do that, I want to make a very short digression into the world of influencers. So let's say you are a very, very important content creator. You have important content that the world needs to see. And you're wondering, like, how are people going to see my content? So the old school way, before the internet, is you had to track people down and be like, here, look at this cool thing I made. And it's a very slow, very time-consuming process because anybody who wanted to see your content, you had to go find them. And so then, but now we have a much better way of doing this. And this is why even the concept of an influencer exists, is that now you can essentially say I'm a person who's going to make content. Maybe I've already made a few pieces of content, and then I put it on some large, surveilling social media platform, and then people can say, I like your content so much, I'm going to subscribe to it. And then essentially every time, I upload a new video to YouTube, I make new content. Rather than me having to go find all my followers, they essentially just get a notification that something has been changed. So in the observer pattern this is basically the fundamentals of the observer pattern. Essentially, you have a thing that says I'm going to emit events. Something, like you could have a thing that says I'm going to emit every time there's a mouse click, right? And then you have code. You basically subscribe to that thing, and then every time that event happens, you get to do something with it, right? And so now it's starting to look like something that might be pretty familiar to you if you've done JavaScript programming. In fact, so in fact, we do this all the time in JavaScript programming. And I want to show you how it actually works in just the good old-fashioned environment of the DOM, right? So let's say that we have a DOM element that's a toggle switch, right? It's just somewhere on the page is a thing we can click to toggle something, right? And we've looked it up. And then we also have a function that, when called, takes another element and changes the text of it, right? So you can see that you can imagine this being the light bulb, right? So this function, when run, will change the text of the element that actually has the ID toggle from on to off and back again, right? So how do we connect this function to us clicking the toggle switch so that when we click the toggle switch, the text on the other element changes, right? So we essentially subscribe to, we have the DOM provides an API to subscribe to the click event on the toggle switch, and then we pass it our event handler function, the modify text here, and then that function is now an observer that gets called every single time I click on the switch. So now when I click the switch, it'll toggle the other element, the text in the other element, from off to on. So that's basically the observer pattern, right? That's kind of all. So now each time we click, this function gets called, it switches the toggle, right? So why is this better than maybe the global event bus? So there's a couple of really cool advantages. First of all, it's really clear and it's really simple, right? We just have a function, we tell it what we want to attach it to, and that's all we have to do. The other thing is that the scope is super localized. We don't have a giant switch statement. We're not dealing with every possible event. We're only listening to the events that our program cares about. And then the possible downside here is that you have to set up these subscriptions, right? You have to write the code to attach and deattach to different events. And that actually is a small thing until you get into like more complicated things, more complicated types of user interactions. I don't know if any of you all have ever tried to implement a drag and drop using like basic DOM events like mouse up, mouse down, and mouse move. It's pretty complicated. And the reason being, like what you end up having to do is you end up having to like make a handler for mouse down, and then when mouse down gets called, you like subscribe to the mouse move until the mouse up gets called, and then you unsubscribe to the mouse move. And so it's like there's a lot of kind of complicated setup and teardown logic while you're trying to handle these events. And eventually you end up mixing concerns, right? Your event handlers are both handling the events, but then they're often like adding and removing other subscriptions, and it starts to suddenly get really complicated again. And so actually, my view is that maybe this is where the Redux folks were coming from, is that they were looking at the difficulties and the complications of the observer pattern, and essentially they kind of were like, whoa, maybe that global event bus has something useful to it. And I think there's an argument to that. But at this point, you might be wondering, is there a better way? OK, and that brings us to the third portion of our talk. So how can we use functional reactive programming to write front ends like a boss? So I want to rewind to our original metaphor. Once upon a time, I was actually a middle school teacher. I was actually really bad at it, so this is not a talk about how I ran middle school, but it's a talk about how good teachers handle middle school. I don't know if you've ever seen a good teacher in operation, but they're kind of like Jedi with the students, right? Like somehow they just have this like way of like Obi-Wanning the students into being like, this is the lesson that you want to be listening to. So how do they do that, right? Well, the first thing they do is they don't start with like a strict lesson plan. They have a lesson plan, but it's kind of like more like what I'm trying to do in the broadest sense. Because if they did, they would just like try to go directly through their lesson plan, they'd get interrupted, right? If you actually look at how teaching works, you can almost think of it as like a series of like semi-planned responses to interruptions, right? So really good teachers know how to respond like to basically as they get interrupted, they just kind of like have this way of folding the question or the acting out or whatever it is into the lesson. And they often have a way, like if somebody asks a question, even if it's like not the question they were expecting, they have a way of like folding it back into like the actual learnings of the lesson in this sort of way where it's like this stream of interruptions and responses just inevitably moves towards the ultimate like kind of like main objective learnings of the lesson. So in that sense, it almost is like Jedi mind control. Very brief PSA, teaching is much harder than programming. Sorry to all of us. And we should be paying teachers like we pay programmers. Anyway, so how could we program like this, right? How could we write programs as a series of planned reactions at being the core concept of what we do, right? How can we write it, rather than writing as like a sequential program that we like get interrupted on, how can we write a program where essentially our entire program is reacting to things and then like slowly cascading towards our end goal? And this is the underlying concept of reactive programming. And to kind of talk about how this would work, let's think about a really simple programming statement, right? Y equals x plus 3, right? You've probably written something like this in a program at some point. So in a traditional imperative program, we know what this means. It means take the current value of x, add 3 to it, and assign it once to the value of y. So now y has a value of x plus 3, that one time, right? Just once. But that statement actually, if you take it out of the programming context and maybe think about it in terms of like the math, like a math context, like y equals x plus 3 actually describes like an entire like graph right? Like I don't know if you all remember like the old school like slope intercept. I can't remember any of the terms, but like that's a graph of y equals x plus 3, right? It actually represents all the possible values of y given possible values of x. And so in reactive programming, the meaning would be that there's a relationship between x and y. And whatever the current value of x is, then y is always going to be that value plus 3, right? No matter how many times x changes, y is going to immediately become that value plus 3, right? Let's imagine like we have x values over time, right? So this is a stream of like x values over time. You have like 0, 9, 3, 10, 4, right? So then like y would be another stream of values where each time where essentially each one on that stream is the value plus of the x stream plus 3, right? I mean, makes sense visually, even if it doesn't make sense how it's going to work programmatically. We'll get to that. And you can imagine that like a stream could really be anything. Like a stream of values could be a stream of every time the user clicks the mouse, right, over time. So that's abstractly what reactive programming is. But let's talk about what would reactive programming look like in the real world. Because obviously, at the end of the day, our computers are running instructions through a good old-fashioned processor. So how could we write this in the real world? What we would need in order to do this is we would need some kind of pattern for when you have a value that changes over time. You would get notified that it had changed, and then you could do something with it, right? So that pattern sounds maybe a little bit familiar. It's actually just the observer pattern, but we're going to augment it and make it a little bit more abstract. We're going to extend the observer pattern. That's the basis of functional reactive programming. So in functional reactive programming, you have this concept called an observable. An observable is just like the DOM element that emits clicks in our traditional observer pattern, but it can represent anything, right? It's essentially any value that changes over time, right? And let's just look at some like how it would work, right? And this is some abstract code, but we're going to start to get towards some real code in a second. So let's say that we have an x observable, and it has a subscribe method, right? It's essentially the same way you would attach to a DOM event. And every time x changes, the function inside of subscribe gets called, right? In this case, we're just writing out the value. So this, you could say this line would write out the values of x as it changed. And you can imagine that you could write out the values of y pretty easily if you just essentially subscribed and logged the values of x plus 3. But you might be wondering, well, what if I want to subscribe to the values of y? Well, let's think about how we would, how would we write y as an observable, right? So we think about, let's just rewind and imagine that x is a plain old JavaScript array, right? Let's say we wanted to make an array of y values out of this array. Anybody have a function we could use for that? What? I heard it over there? Map. Yes, map, right? If we wanted to take these values and make an array y out of the values, wrong one. Out of the values of x, we could just call map, right? This would produce an array of all the values plus 3. Well, so basically, observables are the exact same way. So here we have x as an observable of these numbers. And this is just one way we could build an observable. We'll get to the library itself in a second. And then if we wanted to make an observable y, we could just call map on x and use it just as if it were a regular array, except here, this isn't a fixed set of values. It's a set of values that can change over time, right? You might get all these elements at once. You might get them over a long period of time, right? But you're transforming each one to get the new stream that you could listen to. And then you could subscribe to y as well. Cool. So that's really awesome. Let's talk about what it would look like in an actual DOM, the world of DOM events, right? So here we have a go left button. Oh, here's the part where I would be, OK, this is going to be a little tricky to do. But here we have a go left button and a go right button, and we have a ball in the middle, right? Oh, God, this is going to be tough with the screen going super slow. All right, so let's go ahead and do, if we click the go right, which I can't see very well here. Oh, there we go. Yeah, it's going to pop over to the right. And then if we click the go left, it's going to pop over to the left, right? This is just, so how is this implemented, right? So let's imagine we have a stream of left button clicks and right button clicks, right? And so every time I click the left button, we get a little click on the left. And every time I click the right button, I get a click on the right, right? OK, so now let's take it a step further. What if we used map to transform each of those clicks into a string that represents the position of the ball, right? So if I click a left, and I get a click, and then it becomes a string left, right? And then if I click a right, and I get the string right, right? So if I wanted to express the current position of the ball, I could take the things that are emitted by each one of these streams and essentially just combine them. So essentially, each time we get a left, the position becomes left. And each time we get a right, the position becomes right. It's just something that's changing over time. Now, I'm actually using a small animation library to make the ball smoothly transition from left and right position. But that's the basic idea. Let's look at how that actually works in code. And so here I'm going to introduce the library that that I'm basically talking about here. It's a library called RxJS. You can see this is the library here. I'm importing some stuff from the library. And in this case, I'm importing two functions to build observables and one function and a couple functions to transform observables. But basically, let's construct. Let's say we have our left button and right button. So we're just using JavaScript code here to get our left button and right button. And then RxJS provides a mechanism for building an observable from a regular DOM event. So in this case, we're making a stream of left clicks and a stream of right clicks by using this from event to get the stream for click events on the left and click events on the right. And then you can imagine that our left click position and right click position, this is just the string, we're mapping the previous stream. We don't even care about what the event actually looked like, because it's just a DOM event. We're just returning the string of the position on each one. You can see it's a little bit confusing, because there's this new syntax called pipe, where you're actually passing map as a function. But basically, same idea. And then if we were to build the stream that is the current position, all we do is we use this function called merge, which is basically a function that RxJS provides to construct an observable by merging two other observables. So this observable emits every single event that either observable sends. And then we just do it. We also use this start with so we can get an initial position. So that's basically all that observables are. Which is super cool, except that you're probably like, that's really neat. It's been really fun talking about theoretical stuff, but how would I actually use this in a real program? I have to go to a job, or I aspire to go to a job and do this. And so first of all, so I'm going to talk about RxJS in the real world. But first of all, I want to identify a very important, an interesting data point. I was recently at JSConf, and someone gave a talk about basically what libraries in the React ecosystem are being used. And they're like, oh, yeah, there's React and Redux and React Router. And you can see how that. And then I was like, when I was watching this, and he didn't mention it during the talk, though I talked to him afterwards, I was like, what's that green line? I was like, wait a second. What isn't that? Oh, my God, it's RxJS. And it has more installs than React itself. holy moly, I'm using the most popular library in the world. We actually talked later. As it turns out, the reason is that there are a couple of very key large-scale open source libraries that use RxJS. Angular, the framework, integrates it a lot. And then also, actually, ESLint depends on something that depends on RxJS. So between those two, particularly ESLint, you get like a lot of use of RxJS. And this may not be super relevant to you, except to say that this is something that the people who write the code that you use every day think is worth using, right? So you're already using it accidentally. But let's say you're not a fancy open source library creator, and you're just writing programs, and you want to know how to use it. So I want to address two different questions. One is like, how do I actually build applications with this? And then how do I integrate this in an application today, right? That I'm, with the frameworks I have. So I want to give a real-world example of a login form. I know I'm going a little over time. I'm going to move as quickly as possible. And again, once again, this is the unfortunate fact of, where's the mouse cursor? Oh, there it is. Yay. OK. So you can imagine like a username and password form, login form. This is something that like probably a few of you guys have written during your time as programmers, right? And you type in a username, you type in a password, and you submit it. While you're submitting, you probably want to prevent the user from submitting again, because you don't want it's going to have to make a backend request. Eventually, the backend responds. You get some message like you used the wrong username and password, right? So if we were to build this with observables, let's say we start with three streams. We have the username stream, which is just essentially it emits every time the value inside that inbox changes. We have the password stream, which emits every time the value inside the password change, and the submit button, which emits every time the submit button is clicked. So just to show you briefly, like this is a new type of observable. So you can imagine that this is emitting every time I type. You can see it's like got a bunch of emissions there. And so then let's talk about the next thing, which would be, as soon as this goes, no, what are we doing? What's going on? OK. Let's re-click over here. Oh, wait, I have to click out of the, there we go. Yeah, so let's imagine that, let's talk about like how these would get combined. So every time so once you have username, password, and submit button, you could probably come up with a stream of attempts to log in. Basically, the logic for that stream would be every time you click the submit button, take the last two values, the last values from username and password, and send them to a server, right? You can imagine an attempt stream like that. And then every time that you, where's my, sorry, I had a monitor to look at last time, and that's my bad. But every time you submit, right, you can imagine, right, like it's like building an attempt from the last login and password. And then if you imagine that you have an attempt, you're probably eventually going to get a response from a server, and you might have a stream of all the times that the server responds back. And then once you have a response, you can probably figure out if it's a success or a failure. And you can use the time between attempts and responses to create a stream of whether or not you're currently trying to log in. And then once you have the responses, you might want to do something with it, like take the login failure and convert it to an error message, because right now it's incorrect username or password. It could be something else. And then if you have a success, you probably get a token from the server. Maybe now you want to go on to the next screen and send that token into like a protected endpoint and get a protected resource back. And that you could have a stream that's pretty complicated. So let's talk about how this would. So like if we watch this go through the real world, right? We submit. Right? And then that makes an attempt, then that makes a response, and you get a failure, and then it cascades down to the username and password. Sorry, the error message. And then if you imagine we had a success, oh my God. Sorry, this is, I apologize for not running this particular slide very well. I'm going to have to type in the correct username and password. This, by the way, is not actually connected to a backend, but it is connected to an API that returns promises and is delayed and only accepts one thing as a valid response. And this is going to be, you can see this is a highly secure password form that does not hide your input. And then let's just go and try submitting, right? And you can see there you have there's your attempt, there's your success. You get a token, maybe hit an endpoint, and then you finally get like your protected stuff, right? OK, so like that's super cool watching things happen. But how would that actually work, right? So let's say we have an API and it has a login method and a protected resource method. And all I have here is that these don't really say how they work. They're just imagine they both return a promise that either resolves or rejects, right? So that's our API. And then let's say we have a username, a password, and a submit button. Right now it says new subject. I'll explain that in a second, how that works with this. So you have a username, a password, and a submit button. And then you can express the login attempts as essentially a transformation on the submit button with this other new operator that RxJS provides called with latest from, right? So basically, this operator transforms the login attempts to something that emits every time that the submit button is clicked, but it attaches the last value from those other two streams, right? And so then, once you have that, you can just take the username and password and send it to the API. And there's a crazy new operator here. Because, right, like the login response is we send it off to an API request, right? And that gives us a promise back that doesn't resolve immediately. So we actually, normally, if we were just using a map, we would get an observable promises, which isn't very useful. But RxJS has this really cool operator called merge map, or sometimes people think of it as a flat map, that takes this promise and it actually doesn't emit till the promise resolves, and then it emits the value that's inside of that promise, right? So this is going to become a stream of either the promise returning or the promise not returning, either a success or a failure. And then it's pretty trivial from there to make essentially whether or not the login is in progress. That's essentially just mapping all of the attempt emissions to true and all the responses to false, because once the response emits, that means it's come back. And then you can pretty easily come up with the successes and failures just by maybe looking at like a status on the looking at a status on the response. And here we're using an operator filter, which is like an array filter, just like the array filter, where you're basically cutting down the emissions to only the ones that match those criteria. You can do the same thing with the failures. And then you could probably make the failure messages by just essentially mapping out, taking the body of the response failure and mapping it to extracting some piece of text from it. You could get the user tokens by doing the same thing from the login successes. And then once you have those login successes, you can kind of start the cycle over again. And now you have a stream of events that comes from your user token and maps it to a new request, which is to some sort of protected API, and finally lands on some, and then you finally get a response of protected data, right? So that's kind of the basics of how RxJS works. That graph that y'all been looking at, those like the way that signals or the way that like emissions from observables flow through your program, that basically describes the overall operations of your program. There's a term for that, and it's called a signal graph. It's basically how data propagates through your program. And you can think of this as the template for essentially how your program actually is going to respond to interruptions over time. This is an actual signal graph that's taken from a production program. A lot of the time, my coworkers and I, when we work with RxJS, we tend to like build these using like a charting program and track it, because it's a really useful visualization of how the different pieces of data in your program interact with each other. And so that's like the basics, but let's just talk about it one more level of like real worldness, which is like how do you actually integrate it with like today's JavaScript frameworks. So the first one is Angular, and this is really easy. It's very RxJS is actually integrated all throughout the Angular framework. So it's kind of done for you. There's also some support libraries like NGRX, which kind of adds some more like Redux-like patterns to RxJS. I don't know if that's of interest to you, but yeah, it's pretty easy. But everybody's using React, so what about React? right? Like we got like a reactive library, a reactive programming, like we need to get some React in our React, right? So there's the good news, and there are a few libraries out there for this that you can use. I'm going to promote one. It is actually the one that I wrote, so just pure coincidence. Anyway, I wrote, but I'm actually not making a judgment. This is just to give you a sense of how this could work. This is called, it's called RxReact. Really interesting name. And it's a bunch of it's tools for integrating React with RxJS. Let me show you the demo for this. Is actually all of these slides you've been watching have been written with this tool. This is a React spectacle presentation, and in it are a bunch of React components that are connected to observables. That's how all that like visual animated signal graph was done. And so let's look at the position box example, which is a pretty simple one. You have, let's say we just have a positioned box, right, that takes a position and moves the box back and forth, right? And so the way you essentially what am I doing here? Can't remember. Oh, right. So yeah, this is just a box component connected to this animation library. And then what you do in React is you define what's called a view model for that box. It's sort of similar. If I don't. This is somewhat taken from Swift programming on iOS because these libraries exist there too, and there's this concept of a view model, which is like the data that backs the view you're about to render. And so here, the view model essentially just has one input, which is a position, which is taken from a position stream. And so what this is essentially, so each input here is an observable that will become a prop to that React component. And essentially that prop will change over time every time the observable emits. You bring in this method. This is the core functionality that RxReact provides. The package is called @RxReact/core because someone is sitting on the plain name and hasn't updated their package in 4 years. So here you are essentially taking, you call this function and you pass it a view model. And then you pass it a component. It's a higher order component, very similar to the connect in React in Redux. And you connect it, and this will take the position box and cause the position boxes and return a new component where the position will update every time that position observable emits. So it's actually a pretty simple API. You can also do outputs the same way. So here you give it an observable that receives emissions. This is called a subject. That's what you might have seen earlier. So you have a left-click observable it has to be of type subject. And what this will do is this will provide you an on-click property that is a function that you can call. And whenever you call that function, it will emit a new value onto the observable you've given it, in this case, the left click, right? And that's pretty much all there is to this component. This seems like pretty simple, but if you actually look at, so this is slightly similar to map dispatch to props in Redux. So this right here is the entire code for connecting that login form to all those observables. It's actually pretty straightforward on the scale of things. Sorry. You have an input of a username stream that you want to give it this just is giving it an initial value. You have another input of whether there's a login in progress. You have another input of a failure message. And then the outputs are just whenever the username, password, and submit change. And then everything else is just observables, transforming with whatever comes out. OK, and this is the final wrap up, which I call the used car salesman portion, where I tell you all the awesome features in like a minute. The cool thing is, there's some even more complicated things. I call them view model factories. This is if you want to make your view model change every time, make it respond to changes in the external props to the component. So you can do that. It's like here you would basically make something that would emit a hello plus the name property every time this observable emitted. And that's pretty cool. Some of you all might like TypeScript. How many people like TypeScript? Oh, wow, this is a tough crowd. I love TypeScript. So RxReact is written in TypeScript. But you don't have to have TypeScript to use it. But if you do use TypeScript, you get some super awesome type bindings that force you to write your components with correct types, which is really exciting. Could you make a reducer out of this? Well, I don't know. Maybe you could. You could actually make, there's another method in a different package called viewModel_from_reducer, which allows you to write components with like their own reducers. This is similar, the API here is pretty similar to the ReasonML API. If any of you all know what that is, it's like Facebook's like future React thing. So this is the API they provide. I was like trying to emulate it, mostly as an exercise. That's the name of that package. What if you could generate those signal graphs automatically from your Rx React components? Well, not quite. I just think it would be super cool if you could. Because it would be really cool to be able to like watch data move through your program. And I think it could be done. And I've been working, and in the course of writing this presentation, I've kind of like moved towards it. So maybe one day you will get an Rx React signal. I don't know. That's all I have. Thank you all. Questions, though I've gone over. Yeah.